Okay, so let's work on some concrete examples. So the directions say, and again, these are the identical directions on your ICA. It's going to say solve, right? Implying solve the equation and check each equation. And you'll notice that the checking part is really what you were doing in 6.1 when we were evaluating algebraic expressions. So again, we're building these skills, and your foundation is important. So if you understood 6.1, the checking part is going to be very, hopefully, easy. So let's start with some examples. So I'll just call this example one. And again, these are not the ones in your book. These are just other examples, but feel free to look at the book as well. But these are specific ones that are going to be very similar to your ICA. So we have x plus 3 equals, okay, 17. Okay, this is a linear equation. Okay, here is my left-hand side, right? LHS. Here is my right-hand side, okay? And again, here is an algebraic expression, right? I have variables, I have numbers, and I'm adding them. I mean, that's an algebraic expression. This is also an algebraic expression, right? It can just be a number, that's fine. So here, I want to solve for x. Solving for x, so this is the first one, so I really want to go step by step here. Solve for x. Okay, what does that mean? Those arrow means. It means isolate the variable, whatever variable they give you in this case, x. Isolate the variable on one side of the equation. Okay, you can have it on the left-hand side, you can have it on the right-hand side. It doesn't matter, you know, x equals 1 and 1 equals x is the same thing. As long as you isolate, okay, get it all by itself, isolate the variable. Okay, so that's the goal. So back to our equation, x plus 3 equals 17. And again, this is a linear equation because the highest power is 1. So where's my variable? My variable is right here. So it's on the left-hand side, so I'll just keep it on the left-hand side. Let me say a couple of things again before I forget here. What this is asking for is, so in my last I believe I did it purple. Let me just be consistent here. So my variable was purple, so isolate the variable. So what number plus 3 equals 17? That's basically what it's asking. What number plus 3 is 17? Well, I mean, you can just quickly figure it out. It's going to be 14, right? 14 plus 3, right? 14, 15, 16, 17. So I know the answer is going to be 14. Now, these are nice natural numbers, so it works out nicely. It's not always going to be natural numbers, but if it is, I mean, that again, that's really what it's saying. Oh, a lot of good stuff here. I don't want to miss. You can think of the equal sign. I'm just putting this little dash line here. This is nothing mathematical. Uh, Sometimes students like to put a vertical little line, or when I work with elementary students, either a third, fourth, or fifth grade, and they're solving these equations, they like to put this little dash line, and it reminds them of like a little bridge, right? And there's one side of the bridge, right, and the other side of the bridge. And again, that analogy helps. If not, you don't have to use it. I just thought I'd throw that out there. Okay, so we have, and again, I will not be, this is a very short problem, but you're probably noticing I'm spending a lot of time on it. But again, everybody's at different paces, and I'm trying to erase this bridge here, but okay, it's not working. Okay, let's actually, x plus 3 equals 17. Okay, I want to know what x is. X is right there. So here is plus 3. So I want to use the addition property of equality. So I'm really going to add negative 3 to both sides. So another way of saying that is just saying minus 3 minus 3. I mean, technically, again, you can write plus parentheses negative 3, but there's no need. So I'm going to, I like to work vertically. If you want to write the minus 3 on the, whoops, on the, you want to work horizontally, you know, put minus 3 here and minus 3 here, that's perfectly fine. So why did I do this? Well, because what's 3 minus 3? That's 0, so that cancels. And then I'm left with x, right, which is really 1x if you want to write 1x. And then 17 minus 3 is 14, right? 1 times x is x equals, so x is 14. So we call this the solution to the equation. Okay, and one way of writing this solution, so maybe write solution set. Now let's connect this to set theory, right? We have an answer, right? And it's a set, right? In roster method, right? I mean, technically it's just, there's only one answer, so all we have to write is 14 in there, and there's no more, so we can close it. So that's the solution set. Now let's go back to the problem and the other part, let's see, instructions. Okay, so solve. Okay, so check. We already solved. The answer is 14. So check your solution. Okay, so I'm going to start using some more algebra terminology. So checking your solution. So check your, well, let's go. We know our solution. So let's check x equals 14. Okay, that literally means we're going to evaluate here. So what's our original equation? It was x minus 3 equals 17. And just kidding, x plus 3 equals 17. So checking means we're going to evaluate, right? We're going to substitute that 14. So does this work? 14 plus 3 equals 17. Now we know it does already. I mean, you can quickly add it, but when you check a problem, okay, you have to write the original equation, which, I mean, this is the original equation, and you have to write a little question mark here because, I mean, this is an easy one, but later on they're not, I mean, you're going to have a lot of fractions, and because you're determining, is this side equal to 17? And well, yeah, if you add them, you get 17. But this is an easy order of operations. You're just adding. So 17 equals 17, check. And actually, I mean, this is a, right, this is a true statement, right? 17 does equal 17. I mean, if you get a false statement, then you know 14 is not the answer. And just some terminology here. This is in your book on page 351. So the fact that 14 is a solution, this is important terminology. Okay, we say, so we say 14, right, is, well, okay, so we say 14 is a solution, we know that, to our equation, right? In this case, solution to x plus 3 equals 17. Okay, another way of saying that is 14, right, satisfies the equation x plus 3 equals 17. Okay, these are analogous, right? 14 is a solution to this equation. Another way of saying that is 14 satisfies this equation, meaning when I substitute, right, our proposed solution back, or proposed answer back into the equation, I generate a true statement. Okay, so again, some terminology. I'm just trying to see if I'm missing anything. Satisfy solution set. Okay, so again, this was about 10 minutes. I know it's a very easy problem. Some of you know how to do this problem already. That's fine. But I want you to be comfortable with the terminology. Okay, which satisfies. When we say when we talk about solution sets, true statements. Whoops, true statements, and checking your solution. Okay, and one last thing. This is called a one-step equation because we only did one step, right? We only did -3. We're going to have multi-steps, but this is the kind of general idea.